Today is May 29th, 2026, day 90 of the Iran and United States conflict. And while the world is watching IRGC boats sinking in the Strait of Hormuz, while anti-ship missiles are being intercepted over the Persian Gulf, while diplomats argue in Doha about whether uranium gets turned over before or after sanctions are lifted, the United States Department of Defense just released something that every adversary on Earth needed to see. Not a weapon that has already been used in combat, not a platform that has already been deployed to the Gulf theater. Something that is coming. Something that changes the mathematics of air combat so completely that the gap between what America has right now and what America will have in 2028 represents a qualitative leap that no adversary country currently has the technology, the engine, the manufacturing capacity, or the artificial intelligence integration to match. The F-47, the world's first sixth-generation combat aircraft. Boeing was awarded the $20 billion development contract for this aircraft on March 21st of last year. President Trump announced it personally. The Air Force Chief of Staff stood there describing the most advanced, most lethal, most adaptable fighter aircraft ever built by any nation at any point in the history of military aviation. And Defense Secretary Pete Hegseth just released footage confirming this program is moving forward as the centerpiece of a $1.5 trillion defense investment that also includes collaborative combat aircraft drone wingmen, directed energy weapons, advanced cyber operations, artificial intelligence integration, Space Force expansion, and the most comprehensive drone warfare investment in American military history. This is not a press release. The F-47 is flying right now. Images showing variants of the aircraft conducting test flights at Area 51 have appeared publicly. The program is real, operational, and on track for combat squadron delivery in 2028. And the reason the timing of this announcement matters for the Iran conflict specifically, for the China-Taiwan calculation, for the Russia-Ukraine trajectory, and for every adversary government that is currently recalibrating its threat assessment of American military power, is that the F-47 is not simply a better version of the F-35. It is an entirely different category of aircraft representing an entirely different category of warfare. The gap between 5th generation and 6th generation is not an upgrade. It is a paradigm change. And today, this script is going to give you the complete picture of what the F-47 actually is, what its drone wingman ecosystem means for how air combat is conducted, why the 3-stream adaptive cycle engine is the most consequential propulsion development in decades, what multispectral stealth means compared to the single-band stealth of current 5th-generation aircraft, why the F-47's 1,000 nautical mile combat radius changes China's Taiwan Strait calculation permanently, and why Iran rebuilding its air defenses right now is the most operationally futile investment the IRGC can make, given what is coming. But let's back all the way up. Because to understand why the F-47 announcement matters beyond the impressive specifications and the program budget, you need to understand what the current conflict in the Gulf has revealed about the limits of 5th-generation aircraft in contested electromagnetic environments, how drone wingmen change the fundamental risk calculus of air combat, and why every adversary nation's air defense investment is being built against the wrong threat. Start with what the Iran conflict has demonstrated about 5th-generation aircraft performance in a real combat theater, because the 89 days of Operation Epic Fury and its aftermath have produced the most comprehensive operational dataset of 5th-generation aircraft employment against a real adversary air defense network since these aircraft entered service. The F-35C and F-35B have been operating continuously over the Strait of Hormuz and southern Iran throughout the conflict. The F-22 has been operating in the theater in its air superiority role. The F-15E Strike Eagles have been conducting precision strike missions. And the EEA-18G Growler electronic warfare aircraft have been providing the suppression of enemy air defenses support that allows the strike packages to operate. The results have been operationally impressive. Iran's integrated air defense system, which on paper included Russian S-300 batteries, Bavar 373 domestically produced long-range SAMs, Khordad-15 medium-range systems, and Tor M1 point defense units, was comprehensively degraded within the first days of the conflict. The combination of electronic warfare from the Growlers, low probability of intercept radar from the F-35Cs, and AGM-88 HARM anti-radiation missiles destroyed the radar sites that the SAM batteries depended on to track and engage incoming aircraft. Once those radars were destroyed, the SAM batteries were blind, and the strike aircraft could operate with significantly reduced threat levels. Iran retained some residual capability, as demonstrated by the MQ-9 Reaper shootdown and the claimed SAM engagement of the F-35 during the ceasefire period, but the bulk of its integrated air defense was eliminated in the initial phases of the campaign. 5th-generation aircraft working in combination with electronic warfare aircraft produced the results the doctrine predicted. What the F-47 represents is the next phase of that capability evolution. specifically designed to make the combination of stealth and electronic attack even more effective while simultaneously introducing the drone wingman concept that removes human pilots from the most dangerous portions of the engagement envelope entirely. Now, let me give you the F-47 specifications and the detail that makes the platform's capabilities concrete rather than abstract. The combat radius exceeds 1,000 nautical miles. The F-22 has a combat radius of approximately 590 nautical miles without aerial refueling. The F-35 has a combat radius of approximately 600 nautical miles. The F-47's 1,000 nautical mile combat radius is 69% greater than either of those platforms. In practical terms, this means the F-47 can reach contested airspace around Taiwan from bases in Guam or Japan without needing aerial refueling tanker support at any point during the mission. This specific capability eliminates what has been China's primary calculation in planning for a Taiwan Strait conflict. China has spent 20 years and enormous resources developing the DF-26 anti-ship ballistic missile and advanced surface-to-air missile systems specifically designed to hold American aerial refueling tankers at risk. China's war game against the United States over Taiwan has consistently depended on a simple mathematical observation. American fighter jets need tankers to reach Taiwan from their available bases at useful operational loads. Tankers have to fly into areas close enough to be threatened by Chinese anti-ship missiles and long-range SAMs. Destroying or threatening the tankers removes the fuel that the fighters need. Without fuel, the fighters cannot operate. The entire logic of China's anti-access area denial strategy against American air power over the Taiwan Strait depends on that mathematical relationship between fighter range and tanker vulnerability. The F-47's 1,000 nautical mile combat radius breaks that mathematical relationship completely. When American sixth-generation fighters can reach Taiwan and operate effectively without needing tankers within Chinese missile range, China's 20-year investment in DF-26 anti-ship missiles as a tool for denying American air power access to the Taiwan Strait no longer produces the denial it was designed to achieve. The tankers can stay outside the threat envelope. The F-47 flies the mission without them. China's anti-access strategy has a gap that is the exact size of the F-47's additional range over fifth-generation platforms. Now let me explain what multispectral stealth means, because the difference between fifth-generation stealth and sixth-generation stealth is the technical heart of why the F-47 represents a qualitatively different challenge for any adversary radar operator. The F-22 and F-35 are designed to have low radar cross-sections across specific frequency ranges. Specifically, they are optimized for radar absorption and scattering in the bands that most commonly used fire control radars operate in, primarily the X-band and higher frequency ranges. This makes them extremely difficult to detect and track on conventional fire control radars. But radar technology exists across a wide spectrum of frequencies, from high-frequency radars down to long-wave VHF radars that operate at very different frequencies. A stealth aircraft optimized for X-band concealment is not necessarily equally invisible to VHF radars operating at much longer wavelengths. This is why some countries, including China and Russia, have invested in long-wave radar systems that they claim can detect fifth-generation stealth aircraft under some conditions. The F-47's multispectral stealth is specifically designed to address this vulnerability. All-aspect broadband low observability means the aircraft is designed to minimize its radar signature across the full electromagnetic spectrum, not just in the frequency bands that traditional fire control radars use. Every angle, every frequency. The skin is designed to absorb and scatter radar energy across the complete range of frequencies that any known or anticipated radar system might use to attempt detection. The tailless design with no vertical stabilizers eliminates one of the primary sources of radar returns on conventional aircraft, because vertical tail surfaces are major contributors to radar cross-section. The thermal signature management system handles the infrared emissions from engines operating at high power levels, which is the primary non-radar detection mechanism that infrared search and track systems use to find aircraft that successfully evade radar detection. An aircraft that is simultaneously difficult to detect on radar across all frequency bands, difficult to detect on infrared sensors because its thermal signature is managed, and difficult to track through any other electromagnetic means, represents a qualitatively different stealth problem from the F-22 or F-35. An adversary, air defense operator who has been told their system can detect fifth-generation stealth under certain conditions, has been solving a different and easier problem than detecting an aircraft designed from the ground up to defeat every detection modality across the complete electromagnetic spectrum simultaneously. Now let me give you the engine, because this is genuinely one of the most significant propulsion developments in military aviation history, and it is the component that enables multiple other F-47 capabilities that would otherwise be impossible. Two companies are currently competing for the final engine contract, Pratt & Whitney with the XA-103 and GE Aerospace with the XA-102. Both are building physical prototypes right now. Both are three-stream adaptive cycle engines. The three-stream adaptive cycle concept is the specific technology that separates the F-47's propulsion system from anything currently operational in any Air Force anywhere in the world. Here is what it means in simple terms. A conventional jet engine has two main components. The core, which burns fuel and produces thrust, and a bypass stream, which moves air around the core to provide additional thrust and cooling. The ratio between core airflow and bypass airflow is fixed at design time. You cannot change it in flight. A two-stream engine optimized for high-speed combat performance at altitude has a different optimal bypass ratio than a two-stream engine optimized for fuel efficiency during cruise. So conventional engines make a design compromise between performance and efficiency that limits both. The three-stream adaptive cycle engine adds a third bypass stream that can be independently controlled in flight. In high thrust mode, the engine operates at maximum combat power optimized for supersonic performance, maneuvering, and high-energy engagements. In cruise mode, the third stream increases fuel efficiency by 25% and extends range by 30% compared to conventional engines. This is the same engine that sprints like a fighter and cruises like a bomber. Depending on which mode the pilot needs at any given moment in the mission, the engine can switch between modes in flight continuously, always operating at the optimal configuration for whatever the current mission phase requires. Beyond performance and efficiency, the three-stream engine provides double the cooling capacity and double the electrical power generation of any current engine. These two specifications are the most revealing clues about what the F-47 will carry, in addition to conventional weapons. Double the cooling capacity is a specific design requirement for directed energy weapon systems. Lasers and high-power microwave weapons generate enormous heat that must be managed, or the systems overheat and fail. An engine with double the thermal management capacity is an engine that was designed from the beginning to power weapons that generate extreme heat. Double. The electrical power generation is a specific requirement for powering high-energy laser systems and high-power microwave weapons that require enormous electrical power to operate. A fighter aircraft engine that generates twice the electrical power of current engines is an engine whose designers specifically planned for weapon systems that require that power level. The F-47 is being built to fly with laser weapons, not as a future option or a potential modification, as a design requirement built into the engine's specification from the beginning. Now let me give you the drone wingman ecosystem, because this is where the F-47 transcends the concept of a better fighter aircraft and becomes something categorically new. The Air Force plans to acquire more than 1,000 collaborative combat aircraft to pair with the F-47 fleet. At a minimum of 2 drone wingmen per F-47, the 665 F-47 planned for procurement are accompanied by over 1,300 autonomous combat drones in a single coordinated operational system. The 3 primary collaborative combat aircraft that are the most advanced in development are the Anduril Fury drone, the General Atomics Dark Merlin, and Shield AI's XQBA. Each of these platforms is an autonomous combat aircraft with its own sensors, its own electronic warfare capability, and its own weapons loadout. The Anduril Fury has already successfully launched an AIM-120 AMRAAM missile during testing, confirming its capability as an autonomous air-to-air combat platform. The Dark Merlin from General Atomics recently crashed at the company's Gray Butte test facility in California due to an autopilot miscalculation involving weight and center of gravity calculations, demonstrating that development is in the intensive testing phase where issues get found and fixed through operational experience rather than simulation. The operational concept that these drone wingmen enable is the most significant change in air combat since the introduction of beyond visual range missiles. In the current 5th generation operating concept, the F-35 or F-22 pilot enters the engagement envelope of adversary air defense systems and uses the aircraft's stealth and electronic warfare to survive while executing the mission. The pilot is inside the threat. In the F-47 collaborative combat concept, the F-47 pilot manages a formation of autonomous aircraft that enter the threat envelope, while the manned F-47 operates at a standoff distance from the most dangerous portion of the engagement zone. The pilot does not fly into the threats. The pilot directs autonomous aircraft that fly into the threats, while the manned platform conducts operations from a position of reduced risk. Think of it in simple terms that capture the operational reality completely. The F-47 pilot is the quarterback. The drone wingmen run the routes on the field. The quarterback calls the play, manages the formation, makes the decisions about which target gets engaged by which drone at which moment. But the quarterback does not run the ball into the defensive line. The autonomous aircraft do that. The weapons are fired by platforms that the adversary cannot track back to the manned aircraft because the manned aircraft is operating from a position the adversary's sensors cannot detect, doing things the adversary cannot identify as targeting actions because the AI is processing the targeting at machine speed that looks like nothing a human radar operator would expect to see as the signature of an incoming attack. Now let me explain what the AI integration inside the F-47 actually means operationally, because artificial intelligence in a combat aircraft is not simply about automating existing tasks. It is about creating a new category of decision-making speed that changes what is possible in an engagement. Current air combat operates on the timescale of human reaction and human cognition. A pilot detects a threat, assesses it, decides on a response, and executes the response. This sequence takes time measured in seconds to tens of seconds. Against some threat categories, that human reaction timeline is sufficient. Against others, particularly supersonic missiles with very short terminal flight times, it is insufficient, and the system's automated defensive responses must handle the engagement. The F-47's AI integration extends machine speed decision-making from pure defensive responses to offensive targeting, formation management, drone tasking, and sensor fusion across the entire aircraft formation. The F-47 pilot will likely see a display that shows the position and sensor feed of every drone in the formation, what each drone is seeing, what the AI has identified as targets in each drone's field of view, and what engagement options the AI is recommending based on the current threat picture. The pilot confirms or modifies the AI's recommendations, and the drones execute. This is not the pilot flying the drones manually. The pilot is managing AI-generated recommendations across a formation of autonomous aircraft simultaneously, while the F-47 itself operates with AI-assisted sensor fusion, threat prioritization, and electronic warfare management. The cognitive load on the pilot shifts from the physical challenge of flying and surviving in a threat environment to the command and control challenge of directing a multi-aircraft formation across a complex battle space. This is a fundamentally different skill set from current fighter pilot training, and it is why the Air Force is redesigning its pilot selection and training pipeline simultaneously with the F-47 development program. Now, let me give you the Iran angle on the F-47 announcement, because the IRGC's chief negotiator Mohammad Ghalibaf stated publicly this week that Iran is rebuilding everything in its military and that the country has fully restored its combat capability from before the war. This claim deserves honest analytical assessment rather than either acceptance at face value or immediate dismissal. What is genuinely true is that Iran is rebuilding its drone production capacity as quickly as its damaged manufacturing infrastructure and its sanctions-constrained supply chain allows. Shahed drone production at Iranian facilities has resumed, and the IRGC is prioritizing swarm attack capability rebuilding because drone swarms are the asymmetric tool that has produced the most cost-effective results against adversaries throughout the conflict. What is almost certainly not true is that Iran's integrated air defense system, its naval capacity, or its ballistic missile infrastructure have been restored to pre-war levels. Admiral Brad Cooper told the Senate that 90% of Iran's defense industrial base was destroyed. The Khorramabad and Tabriz underground missile complexes were collapsed with personnel inside. The coastal SAM networks near Bandar Abbas have been struck repeatedly, and the surviving systems have been forced to operate in a mode where turning on their radars invites immediate harm missile engagement. Rebuilding those systems requires manufacturing capacity that was largely destroyed, supply chains that are strangled by sanctions, technical expertise that has been depleted by commander eliminations, and time that the blockade's $500 million daily cost is not allowing. Iran can rebuild its Shahed drone stockpile faster than it can rebuild its air defense network because Shahed production requires simpler manufacturing infrastructure than the radar systems and SAM batteries that constitute serious air defense. The IRGC is doing what a militarily depleted institution does when it is trying to maintain operational relevance. It is rebuilding the capabilities it can rebuild quickly, which are the cheap swarm drones, while publicly claiming to have rebuilt everything, which it has not. And it is doing all of this while the United States is developing a sixth-generation aircraft that is so far beyond the threat environment. Iran's rebuilt air defenses can address that the entire rebuilding effort, even if it succeeds, produces nothing that meaningfully changes the military balance. Now let me give you the Space Force dimension, because this is consistently underanalyzed in coverage of American military capability, and it is a fundamental enabler of everything the F-47 ecosystem requires to function at its designed capability. The F-47, carrying 2 drone wingmen with AI-assisted targeting and sensor fusion across a formation of multiple aircraft, is not a self-contained system. It is the terminal layer of a kill chain that begins in space. The satellites that provide the global navigation positioning data that guides autonomous aircraft to their targets. the communication satellites that maintain the data links between the manned aircraft and the drone wingmen across the formation, the intelligence satellites that build the target picture that the AI systems on the aircraft are trained against, the signals, intelligence satellites that collect the radar emission data that ground-based analysis converts into threat libraries loaded into the aircraft's electronic warfare systems before each sortie. Without Space Force operating and protecting those satellite architectures, the F-47 drone wingman concept cannot function as designed. The white gloves of the Space Force operators represent the invisible enabling layer that makes every visible capability of the F-47 system possible. Every country that is studying how to defeat the F-47 in a future conflict must simultaneously study how to degrade the Space Force satellite architectures that enable it, because degrading the aircraft's satellite connectivity degrades the AI systems, the drone wingman coordination, the precision navigation, and the threat library updates that the aircraft's performance depends on. The Space Force is not a ceremonial organization with an interesting uniform. It is the fundamental infrastructure without which the most advanced combat aircraft in history cannot operate at its designed capability level. Here is the complete strategic picture that the F-47 announcement creates for every adversary currently calculating its military posture. Iran's rebuilt air defenses, even if Golubov's claims were entirely accurate and Iran had restored every destroyed system to pre-war capability, cannot detect an aircraft with all-aspect broadband multispectral stealth across the full electromagnetic spectrum. The radar systems that Iran is rebuilding were designed against targets with the radar cross-sections of F-15s and F-16s. They were already unable to reliably engage F-22s and F-35s under combat conditions, as the Iran conflict demonstrated. The F-47's stealth represents a qualitative advance beyond fifth generation that makes the problem of detection exponentially harder, not incrementally harder. China's sixth generation programs, the Chengdu J-36 and the Shenyang J-50, are flying prototypes with tailless designs that visually suggest sixth generation capability. What they do not have is the three-stream adaptive cycle engine that provides the thrust, the fuel efficiency, the cooling capacity, and the electrical generation that define genuine sixth generation performance. Without that engine, China's sixth generation prototypes are fifth generation performance aircraft with sixth generation airframe shapes. The engine is the capability, not the shape. Russia cannot afford a credible sixth generation development program given the economic consequences of the Ukraine war and the casualty toll that has depleted its defense budget and its industrial workforce simultaneously. The F-47 is not just the next American fighter aircraft. It is the platform that defines the terms of air combat for the next 3 decades, while every adversary is still trying to figure out how to compete with the F-35. Day 90. The F-47 is flying at Area 51. The drone wingmen are passing autonomous weapons launch tests. The adaptive cycle engines are being built by Pratt and Whitney and GE simultaneously in competition. And the IRGC is rebuilding Shahed drones. Iran spent 40 years building underground missile cities to trap the American Navy in the Strait of Hormuz. America spent the same time building the aircraft that makes every air defense Iran can ever construct irrelevant at machine speed from 1,000 nautical miles away without a tanker in sight. Now, let me give you the collaborative combat aircraft crash in detail, because the Dark Merlin incident at General Atomics' Gray Butte test facility in California on April 6th is the most important drone development story that most analysis has missed, and it tells you something specific and important about where the autonomous combat aircraft program actually is in its maturity curve. The YFQ-42A, which is the official designation for the Dark Merlin prototype, went down due to an autopilot miscalculation involving weight and center of gravity calculations in the flight autonomy software. Let me explain what that specific failure mode tells you about the engineering challenge of autonomous combat aircraft development. Weight and center of gravity calculations are fundamental to any aircraft's stability and control. On a manned aircraft, the pilot constantly makes micro-corrections through the control surfaces that compensate for shifts in the aircraft's balance as fuel burns off, weapons are released, and the aircraft maneuvers through different flight regimes. These corrections happen instinctively based on the pilot's feel of the aircraft through the control inputs and the visual cues the cockpit instruments provide. On an autonomous aircraft, all of those corrections must be handled by software that models the aircraft's physical state and predicts how it will respond to control inputs at every moment of the flight. When the software's model of the aircraft's weight and center of gravity does not accurately match the aircraft's actual physical state, the control corrections the software commands are wrong. Depending on how wrong they are and at what phase of flight the error occurs, the aircraft may be recoverable or it may not be. The Dark Merlin crash at Gray Butte was not recoverable. The autopilot commanded control inputs that were inappropriate for the aircraft's actual weight and balance state, and the aircraft went down. This is a normal part of flight test development for any new aircraft, manned or unmanned. the F-35 program, had its share of significant test incidents before reaching operational maturity. The F-22 had software issues that grounded the fleet temporarily after entering service. Every complex aircraft development program encounters the boundary conditions, where the design assumptions do not match the physical reality in ways that only actual flight reveals. The value of the crash is not in the loss of the prototype, which is manageable within the development program's budget. The value is in the data. Every crash produces a data set of exactly what happened at every moment from takeoff to impact, captured by onboard flight data recorders and ground-based telemetry systems. That data set tells the engineers exactly what the software got wrong, which allows them to fix the specific failure mode that the crash revealed. A crash that identifies a specific fixable software error in the weight and center of gravity. Modeling advances the program by producing knowledge that simulation alone cannot generate. The Grey Butte incident made the eventual operational Dark Merlin more reliable, not less, because the failure mode it revealed will be corrected before the aircraft enters operational service. The Anduril Fury, meanwhile, successfully launched an AIM-120 AMRAAM air-to-air missile during testing, which is the most significant individual test achievement in the Collaborative Combat Aircraft program to date. Launching an AIM-120. AMRAAM from an autonomous aircraft is not simply a weapons delivery test. It is a complete system integration demonstration. The autonomous aircraft had to detect a target, classify it as a valid engagement, develop a targeting solution, manage the missile's launch parameters, release the missile in a safe envelope, and confirm the engagement. All of this was done by the aircraft's autonomous systems without a human pilot in the loop. This is the operational concept that makes the F-47 drone wingman ecosystem strategically revolutionary, rather than simply technically impressive. Autonomous aircraft can engage air targets without human authorization at the individual weapon release level, with a human pilot managing the engagement at the formation and mission level, rather than at the individual trigger pull level. Now let me give you the directed energy weapons integration, because this is the F-47 capability that most coverage treats as future speculation, when the evidence from the engine design requirements suggests it is a planned operational system, rather than a potential future modification. The XA-103 and XA-102 adaptive cycle engines both provide double the cooling capacity and double the electrical power generation of any current engine. These are not arbitrary engineering decisions. They are specific requirements that the Air Force gave to the engine developers as design constraints that the engine had to meet. Why would an Air Force require double the cooling capacity and double the electrical power generation in a fighter engine, unless it was planning to operate systems on board that aircraft that require levels of thermal management and electrical power that no current aircraft system comes close to demanding? The answer is directed energy weapons. High-energy laser systems require enormous electrical power to generate the laser beam and enormous thermal management capacity to handle the waste heat the laser produces in operation. A 60-kilowatt laser like the Helios system deployed on Navy destroyers in the Gulf Theater requires dedicated power generation and thermal management infrastructure that a ship can provide, but that a fighter aircraft historically could not accommodate. The F-47's engine specifications suggest that the aircraft has been designed from the beginning with sufficient power generation and thermal management to operate airborne directed energy weapons. A fighter aircraft that can generate and sustain a high-energy laser beam while simultaneously flying at supersonic speeds, managing drone wingman formations, and operating multispectral stealth across the full electromagnetic spectrum, is a platform that changes air combat mathematics in a way that no adversary has yet modeled in their threat assessments. Iran's rebuilt Shahed drone swarms are vulnerable to shipboard Helios lasers that engage at $1 per shot at the speed of light, with essentially unlimited magazine depth as long as the ship's power plant is running. An airborne version of a similar directed energy capability on the F-47 creates the same engagement economics at altitude across the combat radius that the aircraft's 1,000 nautical mile range provides. The F-47 with an airborne laser does to drone swarms at high altitude and long range what the shipboard Helios does to them in the Strait of Hormuz. It makes the economic arithmetic of swarm warfare irrelevant by providing an interceptor that costs essentially nothing per engagement against adversaries spending thousands of dollars per drone. Now, let me connect the F-47's development trajectory to the current Iran conflict's strategic picture, because the timing of the Defense Department's public communication about the F-47 program in the middle of active negotiations with Iran is not coincidental. The strategic communication dimension of releasing information about the world's most advanced combat aircraft while simultaneously conducting self-defense strikes against Iranian military assets in the Strait of Hormuz is a specific and deliberate deterrence message. The message has multiple audiences. For Iran's leadership, specifically the IRGC commanders who have been making the operational decision to fire anti-ship missiles at ships in the Strait of Hormuz during ceasefire negotiations, The F-47 announcement says the following: "Whatever air defense capability you are rebuilding right now will not be relevant against what is coming. The Bavar 373 SAM systems that your generals have been activating and watching, get destroyed by HARM missiles guided by fifth-generation aircraft, are the most capable air defense systems you will be operating for the foreseeable future. The aircraft that destroyed those systems was fifth generation. Sixth generation is coming." For China, which has been watching the Iran conflict's demonstration of American air power effectiveness against integrated air defense systems while simultaneously developing its own anti-access strategy for Taiwan, the F-47 announcement says that the mathematical calculations about tanker vulnerability and fighter range that underpin China's Taiwan Strait strategy are being rendered obsolete by an aircraft that is already flying. The DF-26 anti-ship ballistic missiles that China spent decades developing as the mechanism for keeping American air power outside Taiwan's defense perimeter cannot target what does not need to be in range. For Russia, whose defense industry is already under enormous stress from the Ukraine war's consumption of equipment, personnel, and manufacturing capacity, the F-47 announcement says that while Russia is trying to sustain a conventional ground war that has cost it over 1,355,000 casualties, the adversary it calls its primary geopolitical challenge is simultaneously developing sixth-generation aircraft with autonomous drone wingmen and airborne directed energy weapons that Russia has no credible program to match within any realistic timeline. The strategic communication value of the F-47 announcement in the current geopolitical context is not separate from the diplomatic negotiations happening in Doha. It is part of the same pressure architecture. Every element of the pressure campaign against Iran combines the immediate military self-defense strikes that destroy mine-laying boats and SAM sites with the economic blockade costing $500 million per day, with the diplomatic no-dust, no-dollars framework that structures the deal terms around American requirements rather than Iranian ones, with the demonstration of technological superiority so comprehensive that even if Iran successfully rebuilds its current generation military capabilities, it will be defending against threats it cannot detect. With weapons, it cannot intercept. Using communication systems, it cannot jam. The F-47 is the long-duration deterrence layer of the same pressure architecture that the Patriot PASI-3 and the HARM missile and the CENTCOM self-defense authorization represent in the immediate tactical layer. Now, let me give you the complete honest assessment of what the F-47 development program means for the next decade of American military power and how it shapes the strategic environment in which every current conflict and every potential future conflict will be conducted. The fifth-generation aircraft that have defined American air power since the F-22 entered service in 2005 and the F-35 in 2015 were revolutionary when they were introduced and remain highly capable in the current conflict. Iran's integrated air defense could not reliably track, engage, or defend against the F-35C operating in the Hormuz theater. China's most advanced air defense systems have not been tested in actual combat against fifth-generation stealth. But every simulation and wargame analysis suggests that fifth-generation stealth creates significant detection challenges for even the most sophisticated Chinese radar networks. The F-47 makes those detection challenges significantly harder across a broader frequency range, with a greater range that keeps the manned platform further from threat systems than fifth-generation aircraft can operate. The 1,000 collaborative combat aircraft that will fly with the F-47 fleet create a force multiplication effect that means the adversary's defensive engagement capacity is overwhelmed not by the manned aircraft, but by the autonomous aircraft that the manned aircraft commands from a safe standoff position. Every missile an adversary fires at an autonomous drone wingman is a missile not fired at the manned aircraft that directed the engagement. Every radar that illuminates to track a drone wingman is a radar that is broadcasting its location to the F-47's sensor suite and the HARM-equipped platforms in the formation. The engagement mathematics that have characterized American air power superiority throughout the fifth-generation era become even more favorable in the sixth-generation era, because the autonomous drone wingman absorb the adversary's defensive magazine depth, while the manned aircraft operates without expending defensive capacity. Day 90 of the Iran conflict is the last day of the first chapter of this conflict's air combat history. The second chapter, whenever it comes, will be written with aircraft that are currently flying test missions at Area 51, and the IRGC's rebuilt Shahed drone swarms, its reconstituted coastal SAM networks, and its anti-ship missile mobile launchers will be measured against a threat they were never designed to address, never saw in combat before, and have no current or foreseeable capability to defeat.